The last thing we're going to do with fractions this week are parts of a whole. This is different than parts of a set. We want to look at the whole thing. So this is one rectangle, but it's broken into pieces. How many pieces are there in all? Let's count them. 1, 2. So our denominator would be the number 2. Now, if I was going to go ahead and shade in some pieces on my rectangle, now I have to write the fraction of shaded parts of my rectangle. My denominator is still 2 because that's how many pieces there were all together. And now I'm going to count how many pieces are shaded. Let's count. 1, 2. 2 halves are shaded. If the numerator and the denominator are the same, that's just another way of saying one whole, which makes sense because look, the whole rectangle is shaded in. Let's do another example. We're going to look at the square. How many equal pieces is the square broken into? Let's count. 4. It's broken into 4 equal pieces. Now we want to figure out how many of those pieces are shaded in. So we'll look at the parts that are colored in, because that's what shaded means, and we're going to count them. 1, 2, 3. 3 of the 4 parts are shaded in. 3/4 of this whole square are shaded in. One last example. Here's a circle. So we're going to look at this whole circle. We're going to be like, how many parts is this? Counting parts of a circle can be challenging because you want to make sure you mark this so that you remember where you started. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pieces in this whole thing. Now, I want to know how many of those are shaded in. Let's go ahead and count the shaded in pieces. 1, 2, 3. 3/8 of the whole circle are shaded in. Sometimes they'll ask you to find the unshaded. How many parts of the rectangle are unshaded? 0 halves. How many here are unshaded? 1 of the 4. How many here are unshaded? 1, 2, 3, 4. 5 of the 8. Notice the denominators stay the same, and you're looking at the shaded or the unshaded. You'll practice that today.